Can you see my screen?
Yes.
Yeah.
Okay. Then I will start my training course. Okay. Hello everyone. This is Dennis, and welcome to BMW Lab training course. And today I will introduce the background knowledge of 5GNR Make Scheduler. Okay. And this is the outline for today's training course. And the first part I will introduce the background of the Make Scheduler. And I will also introduce how to do the downlink synchronization for the 5GNR and how to do the uplink synchronization for the 5GNR. And I will also introduce how the scheduler do the time domain scheduling and how the scheduler do the frequency domain scheduling. And the last part will be something I haven't figured out. Okay, and I will start my training course. Okay, and the first part is background. And I will introduce what is the cell, what is the bandwidth part, and what is the make scheduler, and what is the downlink control information. Okay. 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 The first we want to talk about what is the cell. And at the high level perspective, we can easily say that a cell is the covering area of signal from antenna in Geno B. Okay, as the figure you can see, each cell can serve multi-UE, and each cell has the unique cell ID, so we can know that each UE can map to its corresponding cell. And this is what is the cell. And then I want to introduce what is the bandwidth part. Bandwidth part is a part of the total channel bandwidth figured for a cell. In other words, we can say that each cell can be split into multiple bandwidth parts. And the different bandwidth part may have the different bandwidth and different subcarrier spacing. And as this figure we can see, for the bandwidth part 1, the bandwidth equals to the 40 megahertz, and the subcarrier spacing equals to the 15 kilohertz. And for the bandwidth part 2, and the bandwidth equals to the 10 megahertz, and subcarrier spacing equals to 30 kilohertz. So we can choose a suitable bandwidth part for specific UE according to UE's requirement. Okay. So why we need bandwidth part? Can't we just use the scheduler to meet the UE's demand instead of bandwidth part? To answer this question, we need to know that 5G increase the total bandwidth for each frequency band, such as N78, N79, and so on. But each UE may not require such wide bandwidth. It will cause UE needs to sense whole bandwidth, then increase the power consumption. And it will also increase the cost of baseband signal processing. So the purpose of bandwidth part is to save the power consumption, to do the power saving. Okay, and there is an initial active bandwidth part for UE during the initial access before this UE is configured. And each UE can be maximized for bandwidth part, configured for bandwidth part, but it can only active one bandwidth part and at a point of time. As the figure in the right-hand side, you can see an initial active bandwidth part for this UE during the initial access is enabled. And then it's configured by downlink control information here and the inactivity timer. For the downlink control information, I will go into detail later because it's a core information for scheduling. So it's very important. I will talk about that later. Okay, so What is a scheduler? Actually, the scheduler in 5G network is used to allocate a limited resource for transmitting data, including the uplink and downlink. But what kind of resource to be allocated? This resource is called a physical resource block, also known as PRB. It's basic allocating unit, and you can see the figure at right hand side. The green blocks means the resource block, and the resource block engages the 12 subcarriers in the frequency domain. So we know that the scheduler is used to allocate the resource, and this resource is called physical resource block, which engages 12 subcarriers in frequency domain. But how does the scheduler do the scheduling? Actually, a scheduler will get information from user, and this information is called channel state information. It means the UE will report the channel status, channel state information, in order to know the channel capability from each UE. So scheduler can refer to this information to do the scheduling and to do the scheduling algorithm. This is the scheduler. Okay. This page, I will show what is the DCI, downlink control information. Actually, DCI is used to inform UE when and which resource block carries your data, and inform what modulation and coding scheme, also known as MCS. And DCI should be transmit first before transmit the user data, user plane data, such that UE can know how to receive the data correctly. And so before the user transmit the data, or the GNOB transmit the data to user, downlink control information will be integrated first. Or the UE don't know how to allocate the resource, where they can allocate resources. And DCI has a different format according to the different use case. For example, a DCI format 0, 1 in indicates the uplink data scheduling result. And the DCI format 1 is used to indicate the downlink data scheduling result. Okay, then here is another question. How can UE get the downlink control information? Actually, UE can get the downlink control information by monitoring the core set. What is the core set? You can see the figure at the right hand side. It's a set of physical resources within a specific area, which is defined by a RRC parameter. The UE will monitor this physical resource continuously, and UE may receive the DCI, which is for another UE. Anyway, UE will just blind to decode the DCI in the core state area, and try many times based on the UEC RNTI and other parameter until find the correct DCI. And this way is called the blind decoding. And in this figure, we find another things in 4G. In 4G, because it doesn't have the bandwidth part feature, so it can only monitor the whole channel bandwidth to find the DCI. In 5G, it only needs to search the DCI in certain bandwidth part. And that's why here is a new terminology called core set. Okay, so let's talk about the downlink synchronization. Okay, the first I want to introduce what is the downlink synchronization. And downlink synchronization is also known as the cell search procedure or the broadcast procedure. It only happens when UE and GNOB don't know each other. And the goal of this procedure is to that UE can receive the message from the GNOB. And we have to know this preface first. Okay, then let's dig into the cell search procedure. In the first step, UE will tunes the frequency to try to detect the SSB. Just like we are listening the radio, we need to tune the frequency and listen to music or something. And actually, a Juno will broadcast the synchronization signal block periodic, period, periodically. And we assume that UE tunes the correct frequency and receive the SSB. Then UE will decode the SSB. Okay, and let's see what are in the SSB. SSB is called synchronization signal block, and it contains PSS, primary synchronization signal, and the secondary synchronization signal, and the PBCH and master information block. And after this, UE decodes the SSB. The UE can reach the frequency and time synchronization, and the UE get the cell ID of its current cell. And the UE also receive the core set we just mentioned before to get the DCI for the next step. It need to monitor this core set 0 to find the DCI for the SIB1. So this UE will monitor the core set and wait for its DCI coming. After the UE decodes the DCI successfully, UE will know when and which resource block can receive the SIB1. Okay, then after we receive the SIB1 according to the DCI, let's decode the SIB1, and we can find that SIB1 contains the PLM ID, cell selection parameters, and the range parameter. PLM ID is like the Chunghwa Telecom ID or Taiwan Star ID. Range parameter is the key parameter for the uplink synchronization. Until this step, downlink synchronization is done. UE is associated with the cell successfully, and this UE is ready for the uplink synchronization. Okay, then let's talk about uplink synchronization. So, what is the uplink synchronization? Uplink synchronization is also known as the random access procedure, and it only happens when UE finish the downlink synchronization. And the goal of this procedure is to let UE can send the message to the GNOB. Okay, and let's dig into the random access procedure. Because it's the initial access for this UE, so the RC state is idle. In the beginning, UE will send the message 1 preamble, and this preamble is the random number, and we can derive the I and TI from this preamble. Then GNOB will send a DCI downlink control information to tell UE when and where to receive the message to. And message to is also known as the random access response RAR. And it contains the timing advance command and TCRNTI and uplink grant for message 3. And this uplink grant will indicate the UE when and where to transmit the message 3 as well. And message 3 is to send the RC setup connection request to set up the radio bearer. And then GNOB will send the contention solution and the setup RC connection setup. And finally, UE will transfer the RC state to connected. Okay, then let's talk about the time domain scheduling for the scheduler, for the 5GNR. Before we talk about time domain scheduling, we need to know the input-output of the scheduler. And as this figure you can see, the scheduler will allocate the resource according to the channel state information and buffer status report and QoS requirement and the scheduling request. Then the output will be the result of the resource allocation, and it can be composed of two parts. One is the time domain resource allocation, and another one is the frequency domain resource allocation. And we will talk about these two domain resource allocation. Okay. Then let's talk about the time domain scheduling first. Actually, it's not difficult to understand. First, we need to know the unit of time domain allocation is by slot. So as you can see, here are three parameters, which is called K0, K1, K2. And K0 means the time delay between the DCS slot and PDSCH slot, also known as downlink data. And you can see the figure in the right-hand side. And the DCI is located on slot 1. Then we assume that the K0 equals to 2. The UE can know that it need to be get the downlink data in slot 3 because the K0 is 2. So UE know it can get the PDSCH data in the slot 3. Okay, then let's see the K1. K1 means the time delay between the PDSCH slot and UCS slot. And this UCI is used to do the HARQ egg. We can see this figure again. We assume that the K1 equals to 5, and the UE can know that it need to put the HRQ egg in slot 8. Yeah, because K1 equals to 5. Okay, and here K2 means the time delay between the DCS slot and the PUSCH slot, also known as the uplink data. So you can see the figure in right hand side. We assume that the K2 equals to 5, and when the when this UE receive the DCI is at the slot 4, so we can derive that the PUSCH data we can put it into the slot 9. So it's the time domain scheduling for the 5-general scheduler. Okay. In this page, we can see the time domain resource allocation with ASN.1 format for the downlink data, PDSCH, and uplink data, PUSCH. And and you can see in the PUSCH, it contains the K2 we just mentioned before, and it also defines the length of the data and the start and the start symbol and the start symbol of the data in this field. And it's also called SLIV. So it's the time domain resource allocation, the parameter regarding to the time domain resource allocation. Okay, and this part we can talk about the frequency domain scheduling. Okay, for frequency domain scheduling, we all know that the scheduler will allocate the PRB to the UE, but how the scheduler allocate the resource block for each transmission? Actually, it has two ways to allocate the PRB. One is use the way for the bitmap data structure to indicate the location of the PRB, and another one is to indicate the start RB and the number of RB. So we can know the type 0 is more flexible because you can put the PRB in anywhere in this bitmap. But for type 1, you can only set the start of the RB and the number of RB. And this information, the resource allocation type, is also carried by the downlink control information as well. Yeah, And here is something I'm still trying to figure out. Because when I just tracing the code, I can find there's a lot of definition regarding to the logical channel and the logical channel ID, but I haven't found some significant document to tell me what is the relationship between the scheduler and logical channel. Yeah, like the logical channel group, this parameter, and so on. Yeah, and this is my presentation. Does anyone have any question?
Thank you. Thank you
Hi.
for it. Yeah, okay, please go ahead.
Oh, okay. Can you hear my voice?
Yes.
Okay. I want to ask about a term called tune. I will type on the check box. Just box.
Tune.
Yeah, tune. Yeah, I also see this term before, because so I'm wondering what is called tune. To adjust the spectrum or filter. I don't know.
I think it is to adjust the frequency the UE can sense. I think it should be explained like this. Can you get my idea or?
Yeah, I can get your idea.
Okay.
Because something on the internet said the tune they they have they have no idea about the tune, and they just consider tune is just adjust the comfortable position to receive the signal. That's why I concerned about the definition of this word.
Tune. So.
Basically, it's easy to understand this if you know why you want to do this. If you know the whole procedure, you can understand the meaning of tune. In downlink, UE need to find the frequency the general B is using now. So he need to adjust the frequency to sync with the general B.
Oh, okay.
Yeah. Try to understand the meaning. Try to understand the whole procedure, the meaning of the whole procedure, why they need to do it. Then you can understand the wording they use, because everybody use different wording, but the purpose is the same. So you need to always ask yourself, why do we need to do it? Whether we have a better way to do this. Then you can know why they want to implement like this. Okay, thank you.
Okay, thank you.
For Dennis, I
yes.
think you need to do you compare all the information you show to us with the source code provided by OSC? I mean, is there one-to-one mapping to tell us which part of the function you mentioned is implement in which file by Redis, and which of the feature does all the feature implemented, or what are the missing feature?
Okay. For now, the scheduler part. Wait a second. Actually, I don't see any. They don't consider the QoS requirement to do the PRV scheduling, and also the CSI. Actually, they have already create the structure which is called the CSI, but they haven't used this one, so it's just a stop.
Okay, so I think you need to think about this.
Yeah.
And the scheduler, the question you just point out actually is depend on because you want to know the buffer status. You want to know that your scheduler actually they need to do common channel scheduling and the dedicated channel scheduling. Dedicated channel scheduling is related to UE. So for each UE, they have many logical channels. So actually, if you want to know the relationship between scheduler and the logical channel, you can check. You should introduce the fundamental concept of logical channel first.
Yes.
Then you can check the source code provided by OSC and the C.
Oh, okay.
Which of them are used in your in their scheduler, so you can understand. Then you can understand whether the concept you show us is just a general concept, but in the implementation, maybe they don't implement all the detail.
Yeah.
So you need to tell us which part they already implement, which part are missing, and what we can enhance or improve based on their result. Okay.
Okay. I got it.
Okay. Good job. Thank you.
Okay. Thank you.